awesome that you're here. In our last video, we talked about one-dimensional arrays, which you can basically think of as a variable that can contain a list of values rather than just a single value. In this video, I'm going to be showing you how you can use a two-dimensional array to store an entire table of values. And don't worry, we'll have a quick review first. You ready to rock and roll? Yeah! Let's do it. So as promised, let's have a brief refresher before we dive in. For example, if I were writing a program to store my grocery list, with regular variables, I would need to declare a variable for every single item, like this. While that would work, it isn't nearly as efficient as an array, which would instead look like this. By using an array, we consolidate computer memory down to just one variable, while still being able to store multiple values. We also discussed parallel arrays, which are two unique individual one-dimensional arrays that go together because of an association between the order of their elements. Our grocery list array could easily be paralleled with another array that stored the prices of our grocery items, like this. The reason that we have to have these as parallel arrays is because we can't mix data types in an array. So even though this looks like a two-dimensional array, because we've got rows and then also columns, we have a mix of both strings and doubles in our data set. So they are each going to be their own array. With me so far? Good. If we wanted to extend this example, let's say that in addition to the ingredients that you need and their price, we also wanted a column for quantity. Say, if you need more than one of something, well, we can totally do that too. One option would be to create yet another one-dimensional array and parallel it with the two that we already have. But since our item price array is storing doubles, which includes integer values, it would be way more efficient to just expand our pre-existing array from 1 to 2 dimensions. And that's going to look like this. So we still have our string array, but now it's running parallel to a two-dimensional array. And we know that it's two-dimensional because I have my single array here, and then here I've got my item details, which has 2 columns as part of a single data set. Because this array is 2D, we've kind of got this double bracket thing going on. We have the green brackets, which encompass the entire data set, and then we have these pink brackets that are for each row of the data. So in our very first row here, we have potatoes. They're 79 cents. And then our quantity here, we're going to need 5 of them. This comma between the values is the separation in the set. Then we finish up, we go to the next row, and so on and so forth. Still with me? If this isn't clicking yet, don't panic. Before we go any further, I'm going to show you another way to look at this. Okay, so here I've put our data set into a nice table in Excel, and there's a few reasons that I wanted to show it to you like this. First, it's very easy to see the rows and columns, right? We've got our 2 columns for the price and the quantity for the various items from our grocery items array. And now that we can see each data set very distinctly like this, looking at it in syntax form shouldn't be so overwhelming. Now here's the same data set, but in syntax form. And now it's really easy to see how we have the outer curly brackets here in green, and those are what show the compiler where the start and end of our array values are. But then within that, we also have our subsets of curly brackets, and that allows the compiler to distinguish the unique sets of values within the array as a whole. The reason that we need each set of values to have its own set of curly brackets is because that's what creates that second dimension of the two-dimensional array. If we didn't have them, to the compiler, it would look like this. Without that second set of value brackets, the compiler just reads this as a list, which you might recognize this as the syntax for a one-dimensional array, which again, that's how we lose that second dimension, which is the ability to move through columns. And you might wonder, well, why is that important? And that's a totally fair question. It's important to keep value sets together because if I asked you to tell me how many apples do we need, I mean, Like looking at this, how would you be able to tell which one you need? It's just a list of numbers. Even if I told you that quantity was the second column in the two-dimensional array, when you just have a list of numbers like this, position doesn't really mean anything. Whereas when we're using the value set brackets, we could easily go to apples, the second column, and then there we're able to see our quantity that we need 3 apples. So now that we've gone over why we need to use this inner set of curly brackets to keep our data organized, we can talk about the next benefit of envisioning our data as a table. If you aren't super familiar with Excel, you may never have noticed this little box up here in the top left before. I don't know the official name for it, but I call it the coordinates box because that sounds official and it tells you the coordinates of whatever cell that you're on. So I'm currently selected right here on cell B3. So up here, it tells me that my current coordinates are cell B3. Now, obviously, we're not going to be coding in Excel. We're going to be coding out in Visual Studio, but I wanted to point this out because these coordinates that Excel is giving us is a lot like array indexes, and here's what I mean. So here's our one-dimensional array with the indexes for each element next to them. So our first element, potatoes, it has an index of 0. So if I wanted to see out the word potatoes, I would need to call my grocery items array index 0. If I wanted to call apples, we would need index 1, and then so on and so forth. Pretty straightforward with 1D arrays, but when we introduce columns, like in a two-dimensional array, we get this. With a two-dimensional array, we have rows, but then we also have columns, which creates that second set of indexes. So the first index is for the row, and then the second set is for the column. So this cell here, for example, is going to be index 2 for the second row, and then column index 1 because it's the second column. If I wanted to go down here, where we've got just our two-dimensional array, and I wanted to get the coordinates here of this value, then I'm going to look here at my row, which is the first index, and that's going to be 2. And then I need my column index, which is 1. And we put that right here. Perfect. So hopefully this is all making sense so far, but just to help drive the point home, let's do a quick activity. Here in this table, I've got our full data set. So our grocery items array is here in green, and our item details array is here in red. I'm going to ask you guys for some specific data points from this data set, and then we're going to write out the syntax that we would need to call it. So first, how many apples do we need? We know that apples is the second item in our list, so that's going to be index 1, and then we need to go over to our second column to get the quantity. So that's also index 1. So in order to call our quantity of apples, which is right here, we need our item details array, index 1, 1. Great. Next, what about the price of rice? We know rice is right here. It's our fourth item, which means it's going to be index 3, right? And then our price is the very first column, so that's index 0. So in order to call the price of rice, that is also going to be our items detail array. Okay, and then we have row index 3, column index 0. Next, we want to call the name of the third item on the list. So for that array, for humans, we're going to go 1, 2, 3. Carrots is the third item on the list, but what index does that make it? 2, right? So to call that, we need our grocery items array. index 2. Now finally, if we were to write out a statement that was going to call the price of rice and the price of cheese, how would we write that out? We know that they're both going to come from the same array here in items detail, so let's get our index here. It's going to be column 0, so now we just need our rows. We've got rice, 4th item, but 3rd index, right? And then cheese, 5th item, 4th index. So that's going to come out like this. And then column index 0, so that we make sure we get the price, plus and again, column index 0, because that is where we're storing all of our prices. Perfect. Great work today, everyone. I hope that this video helped you get a good understanding of how data within 2D arrays is organized and indexed using rows and columns. To see how we apply this in our program, check out our other 2D array video, where we're going to be having some fun at the keyboard and coding out what we did today. I hope to see you there because, remember, your goals and ideas have value and are always worth working towards. See you next time.